Look at the quiz review number 6. It's graphing two systems of a system of inequality which consists of two different lines. The first line is 2x plus y is greater than negative 8. And the second one is negative 1 minus y is greater than or equal to negative 5x. So we just have to graph those two. Let's take each one and let's solve these separately. So 2x plus y is greater than negative 8. I could get this into slope-intercept form by subtracting 2x from both sides. Like I could have y is greater than negative 2x plus negative 8. And then suddenly it's in slope-intercept form. I'm going to put this over 1 to make it even easier. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Desmos would be more accurate, of course. 1, 2, 3, 4, 5, 6, 7. So the story of this line is that the y-intercept is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Another way would have been to just come up with x's and y's, like make a little table, a chart, and like, what if x is 0, then what's y? What if y is 0, what's x? That actually would have been pretty easy. Actually, let me show you how to do that just in case. So if x is 0, y would have been negative 8. And if y is 0, x would have been negative 4. Yeah, negative 4. That's not so bad. Anyway, but back to this method, we could have just actually, I can plot those points, negative 1, 2, 3, 4, 0. So there's another point. This is the point 0, comma, negative 8. And this is the point negative 4, comma, 0. If we were still going to work on this, the y-intercept is negative 8, slope is negative 2 over 1, so it would have been down to right 1 or up to left 1. Up to left 1, up to left 1. This is a terrible line. Sorry, I have a hard time eyeballing it. All right, so anyway, and by the way, this is a greater than sign, so it's a dotted line. Oh, it was really off in my drawing. So a dotted line. And then we need to think about which direction should we shade. Well, y is greater than the line, so we shade everything bigger than the line. So we're done half the problem. Now let's do the other half of the problem. The other line is negative 1 is minus y is greater than or equal to negative 5x. I am going to, we have options here. I do love a slope-intercept formula kind of problem. I'm going to add 1 to both sides. So I get negative y is greater than or equal to negative 5x plus 1. If I want to get y alone, I have to divide both sides by negative 1. When I divide by a negative number, I have to flip the symbol. So I can get y is less than or equal to, and then change the sign of everything. It used to be negative y, now it's a y. It used to be negative 5x, now it's a 5x. It used to be plus 1, now it's minus 1. So I can plot that. The story of this line is that the y-intercept is at negative 1. So, and then our slope is up 5, right 1. 5 over 1, 5. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 1. Or down 5, left 1. 1, 2, 3, 4, 5, left 1. Oh, I see where it's going to intercept that line then. Okay, so I connect it. Now this is a greater than or equal to or less than or equal to problem. So that sounds like a solid line. I lost my points, kids. That was it. Oh my gosh, this is really not drawn well. Sorry. Okay, solid line. And I might use a different color just for emphasis. I wish I'd done that line in green. I should have done that. Okay. But, and I went, it's y is less than or equal to the line, so it's everything below the line. So now think about this. Here, maybe I'll extend those hash marks too. So where do these, oh man, this is so poorly drawn. So sorry. All we have to do is think about where these two shaded areas intersect. And because I drew it really badly, that's a problem. But this is kind of like what we did with the circles and the Venn diagrams. They both intersect here, for sure. Do they intersect there? You know what? I should have extended this. Oh, right there. That's the border, right here. That's the border. Because this line continues here, and that line continues there. So it ends up being this like kind of trapezoidal-ish, no, triangular blah, blah, blah shape. It's not a trapezoid, it's an angle. It's an obtuse angle. And it just goes on forever. So basically we had to look at the shaded area of both lines and find out where they overlap.